gloves or work wear which you can give it to everyone. You really need to design as per the requirement so that a particular area or particular clients are happy about using the product. So that this is a setup where spot welding is being done, and 100% para-armored gloves were used, which was good. It works out well, but it was heavy because of 10 gauge. So just to give you example, 10 gauge gloves are in the range of 55 gram per pair. So using our yarn, this 15 gauge gloves are developed, which are 35 gram per pair, and it's nitrile coated. So now the workers, they are very happy because they are feeling that this glove is more dexterous, and they can do a lot of maneuvering using their hands, and it's lightweight, and yet cut performance and good coating is there. So it's very easy for a company to win a client after understanding their requirement, what exactly they are looking for, and developing a product based on the requirement rather than just developing a commodity and trying to sell it to so many companies. So this is what the future I believe it should be. This is how we should do it in India. That we should understand the requirement, and it's very important to understand the standards also, which standard they wanted to pass. Example, if a client is saying that I want EN 388 cut level 5 as per ISO 13997, or as per ISO 13997, if they are saying we need a cut performance of level F, so we really need to understand, like that he is looking for TDM tester, not for Coop tester, so that we are talking in the same language. And then selection of raw material. Here also, I would like to give an example. I think PBO is the best example. PBO fibers, Xylon, available in Japan. Even though it's fantastic fiber, but we cannot get it. We cannot buy that in India because it's controlled by a Japanese government. So we really need to understand which fibers we are going to use, and if those fibers are easily available in India or not. So even though fibers are good and properties are okay, but it's not available in India, that there's no point of developing something where you cannot scale it up. So selection of raw materials is very important, and that's where blending comes into picture. So you have to focus on blending technique, how you are going to blend different types of fiber to achieve certain properties. And testing validation is very important. And once again, getting same product every time and bulk trial is again very important. And it's very important to involve end customer. As I said, if product is very good, but end customer is not going to use it, then there's no point of developing that product. So these are the two main standards when we talk about hand protection, EN 388 and EN 407. So EN 388 talks about abrasion, cut, tear, puncture, and impact, whereas EN 407, which is mainly focused on thermal, that talks about flammability, contact heat, convective heat, radiant heat, and molten metals, both small splashes and large splashes. Now here, there are a lot of confusion with clients, or there are a lot of, it's time we need to create a lot of awareness in the industry, because most of the time, just to give you example, contact heat, when we talk about contact heat, most of the companies or most of the guys who are into purchasing of these gloves, they consider that as a temperature where gloves can withstand. Example, if I am saying that I need a contact heat level 4 gloves, so they think that you can use these gloves at 500 degrees centigrade for any number of hours. So we really need to create, we really need to have a lot of small workshop where we need to explain these standards, that the contact heat is a contact heat transmission test. It should not get confused, because what happens, a purchase guy will buy a glove and then he will tell to a labor that, you know, you can use these gloves for 500 degrees centigrade or 300 degrees centigrade for any number of time, and then there are chances of accident happening in the workplace, because uh, the standards are not being explained properly to the user as well as to the guy who is the decision maker in any company. And I can see a lot of even big automotive companies, they are still um, thinking in a different way, and they are not able to uh, understand, like, that standards, what is the actual meaning of standard, and how we should convey this message, so that gloves are used properly, or any technical textiles or products are used properly. And a lot of work needs to be done, and I'll request once again that we should consider some workshops specially focused on, I think ITA has already done that before. Anup sir will explain that later, but yes, it's time we should give more time on these standards. Again, this is a small case study I wanted to share. Both gloves, if you talk about standard, both gloves are giving same result, cut level 5 or cut level C as per ISO 13997. But when you put polyester glass cotton in hot air oven 200 degrees centigrade for 15 minutes, it shrinks and it chars, whereas aramid gloves are still no change in dimension. So all I'm trying to say that it's important to understand, even if a product is passing certain criteria, we really need to understand where it's going to be used and what are the risks involved in the workplace. So example, if a cut resistant gloves are being used in a hot area, we should also consider about thermal properties. So it's really important to use to check the risk, to understand the risk involved in totality, rather than just we need a cut or abrasion and we are not bothered with it, because that's what's happening right now in industry. That, oh, you give me some low cost cut resistant gloves, but they don't understand what will happen if it's being used at 100 degrees centigrade, or like if it's being used in a different department. Because end of the day, sometimes laborers, they don't understand that these gloves have this limitation and these gloves are good for different area. And again, a small case study showing that we have these two gloves, although composition is same, but just because of the TPRs, the left side glove failed the impact test, whereas the right side glove has passed the impact test, although the composition is same. So once again, it's important to understand the whole product, taking together, rather than as long as HPP is there and we have the cut performance, there's no problem, you can put any TPR. We really need to consider about the sewing threads which are being used to stitch, because sometimes if sewing thread is not good, the product fails, then the whole product fails, and there's a huge price for that. So it's really important to understand, or to consider the whole product in the development, rather than just checking the certain raw materials. Once again, what I will do, I have just briefly, I will talk about these are the research scope. These are the areas which I'm working here, and we really want more and more students or researchers, to work in this area, because these are the a few of them are the commercial problem which we are facing. So I'm sure if we are facing these problems, other companies must be facing same problem, and so it's important to solve this problem. This is just to show the different examples of fibers which we are using, which we have covered before also. So Pararamid, you have different brand names available in India: Kevlar, Hiragon, Choron, Metaramid. These are the brands. Modacrylic, FR Viscose. There are other fibers also, but I have just mentioned these are the fibers which are most commonly used, and the brand names of these fibers available. Now, before I get into the 5 areas which I mentioned, it's very important to understand inherent flame retardant staple fibers concept and why we call it inherent. In simple language, these inherent flame retardant fibers, even if you wash it or after multiple usage or washing, the FR properties are not washed out. I think this video will show you difference. The first one is showing you a standard polyester viscose being burned for 10 seconds. And the second video will show what happens when you burn 100% para-aramid. Now, similar result can be achieved using coated fibers also. You can have certain chemicals which can be used for coating, but we always prefer inherent FR because coated fibers can lose their FR properties after washing, and it depends a lot on the washing method, and so coated can become a problem if those are not handled properly. So it's always better to use inherent flame retardant fibers for development related to protective textiles. And I'll discuss what problem we are facing now in today's time, especially in developing nations. A lot of companies are blending inherent FR fibers with cotton or polyester or nylon, and that's where the problem starts. Because what happens when, example, you have a blend where you are blending FR viscose from China, aramid from Korea, and nylon from maybe Taiwan. So you have 4 or 5 types of fiber from different country, and it's being blended in India. And what if that blend composition fails in once it's converted into fabric? So it's very difficult to find out which fiber had the problem. So we are working on developing, because what happens, you get a fiber, then any spinning company will take 4 to 6 weeks, and then after you are going to get it woven, then after weaving. So in simple language, I'm talking about at least 3 to 4 months lead time, where when you know the result of FR properties. And 3 to 4 months, and plus the transportation time of 2 months. So you are talking about 5 to 6 months time when you exactly know what's happening with the blend composition. So what we are trying to develop a simple method where you get fiber in your factory, then immediately you try to pass it through blowroom carding and try to create a sliver. And then you try to do all testing on sliver itself, especially the FR testing, so that at least FR properties of blended materials can be tested very quickly and without using the whole lot, because any weaving company will take at least 100 kg to make a fabric sample. So that at least if you know there's a problem in fiber, you can take immediate action without losing a lot of money. And this is very important, especially now when you have flame retardant polyester available in the market. And many times FR polyester, although it's good for home furnishing, it's not good for protective textiles. But even for home furnishing, most of the time FR polyester doesn't work. And then I can see that same problem happening in future when you blend a lot of inherent FR with non-FR fibers, and not knowing exactly what went wrong. So it's really important for us to work on a method where blended fibers can be tested very quickly before getting into bulk production. This is one example of we are trying to take roving and stitching it and doing the testing. So this is one example of 40% para-aramid when blended, and then comparing with 20%, and then comparing with 60%. So what we are trying to create a library of different type of fibers, and trying to work out their flammability behavior. Even we'll try to develop a shrinkage test, or we are still working on how we can use these slivers so that the results can be repeated. So this is an ongoing project, which I feel is very important for the small spinning company like us, uh, you know, where we know the problem before we open all bells and take into production. Another examples of 40% pararamid blended with FR polyester um, and then the 20% pararamid, then 60% pararamid. So I'll just show the next one. Yeah, this one is your 60% pararamid and 40% mod acrylic, where mod acrylic is dyed in green color. Now, again, this is important. Now, when you buy any fiber, example mod acrylic or metaramid, and you do the dyeing finishing in India, and example a company is doing dyeing finishing, and the company is not following proper norms for dyeing of mod acrylic fiber. So what will happen? They can damage mod acrylic, and the fibers will shrink, and you may not be able to use it. But they will say, oh, our dyeing process was same. So it's very important to have your own testing, or we can develop a standard testing where fibers can be tested in the form of saliva, maybe before dyeing and after dyeing, so that exactly we know where the problem happened and how to solve this problem. So I really believe that we need to work on something where we can develop. This is one example of a meta-aramid saliva. This is 93% para-aramid, 93% meta-aramid, 5% para-aramid, and 2% anti-static. And although it's a very basic test, but this tells a lot about FR properties of these blended materials, and further study can be built upon this concept. Another concept we are working on is double core yarn technique. Now, any ring spinning company, they know that core yarn spinning is not a new technology; it's a very old technology. Most of the time, spandex are put in core, or even filaments are put in core, and ring spinning is done. But what we are working on, we are trying to put two types of core material in a single yarn, and we are trying to make it finer. And another interesting area where we are working is we are trying to put glass in core, and trying to create a balanced ring spun yarn, so that so when these yarns are used for knitting, there is no spirality, or there is no additional process required to make a balanced knitted fabric. So example, right now what happens, if you want to put glass in core, which is a very brittle fiber, either we have to use draft spinning, friction spinning, or drafting hollow spindle. Now both techniques are possible, but it's costly, and so we are trying to do that on ring frames, where we have done some changes. We have made some changes where we can have glass in core as well as metal filaments in core, and um, it can be spun into fine yarns up to 30 tex, 40 tex, 60 tex. Once again, in terms of gloves, you can easily make gloves, very lightweight gloves using these yarns, or these yarns can be woven to make fabric. I'll discuss few of the application. Now, this is one example where what we have done, we have used ultra high molecular weight polyethylene, which is 100 denier, and 30 micron steel wire in core, and sheath fiber is your staple, aramid and nylon, and total yarn is your 65 checks, which I believe is for ring spinning, it's a I won't call it a fine yarn, but for ring spinning with double core, I would still call it good yarn to knit lightweight fabric. This is 13 gauge glove sample I have shared. So you are talking about 250 GSM to 300 GSM, or maybe 230 GSM knitted fabric using these yarns. And we can further go finer, and we are trying to get hold of 50 denier ultra high molecular weight polyethylene, which is uh, which is available, and obviously it's very costly, but it's available. So our target is to develop something in range of 40 text to 35 to 40 text double core, where you have two types of components inside a staple fiber. Once again, it's very interesting area. You can think of a lot of combinations. Example, we can put very fine count woolen yarn inside, and we can have aramid on top. You can have uh, endless applications you can think of, or endless combinations you can think of using this concept. This is just to explain a lot many companies in India, they are trying to replicate core yarn spinning with twisting, which is not good, because twisted yarns, we should be very careful in using twisted yarns for protective textiles, because what happens, majority of the time steel wires are coming on surface, and it will create itching issue at times, and even you won't get good contact heat transmission results, because the steel wire is going to touch both the steel wire is going to transfer heat very quickly. And so it's very important. Although you can see that although the raw materials are same in core yarn technique and the twisting technique, you have aramid, you have steel wire, but still you will get different results because of the way you are manufacturing the product. So once again, it's very important to understand how you are going to use different raw materials to develop a product, because the wrong technology can not only spoil your name or image, but it will give it will create problem to the end user. I've seen this problem in the leading automotive company in India, and when I analyzed their sample, and I found that they are twisting steel wire with Ramadian, and those gloves, although it passes cut performance, but it cannot be used by labor for longer period of time. So it's very important, once again, to understand which technology we should use. Now, this is very interesting application of core yarn, which we have developed. So this is one example of glove. Basically, most of the time, when you talk about very high contact heat protective gloves, or most of the time woven gloves are being used, because of obvious reason. You have woven fabric, they are very tight, and gloves are manufactured using multi-layered. And although those gloves that passes a high contact heat result, but those are not comfortable to wear for longer period of time. So what we have done, we have developed a flatbed knitted fabric, and we have tried to make gloves out of that flatbed fabric. So you can feel each of the finger, and this glove passes very high contact heat transmission results. So you get contact heat level 4, and this is, once again, this is very interesting product. A lot of research and study we need to do. This has passed the basic test. Now we are looking for garment companies who can convert, because this is not a good glove. We've just tried to make a sample for testing. But what we can do, we can supply a flatbed knitted fabric or yarn, and any garment company can take this project where they can make some cut and sew gloves using this fabric. And even researchers, it's a good area to look into, because this is having steel wire inside, so it's giving good cut performance as well as heat, and it's giving good protection against molten metals also. Up to 35 drops, it's passing level 4 for contacted for molten metals as well. So another application of core yarn, where we are spinning ultra high molecular weight polyethylene filaments inside core, and viscose or cotton or cellulosic fibers are on sheet. So like whether it's biker's denim, or it's shirts where you really want cotton next to skin, and the high performance fibers should be inside to give good performance, whether it's cut, slash. So again, it's a very interesting concept using core yarn. Now, this is what I was talking before. We are working on. This is not related to protective textiles. This is related to smart textiles or e-textiles. We are trying to develop coaxial wire, where you can imagine tungsten or steel can be in core. Then you have aramid insulation. Then you have covering of polyester stainless steel fiber covering, and then again you have aramid. So all these things can be done in one yarn using double core technique. Obviously, I won't be able to disclose too much on this concept, but this is very interesting project, and I can see good products coming out of this concept. If we can make a yarn which can work like a coaxial wire, so you can imagine endless application for this yarn, and this is possible. It can be spun, and obviously we need to do a lot of R&D. But yes, we are working on this concept using double core technique. Now, flash fire and arc flash fire. We all know flash fire is a sudden explosion of fire. I have mentioned definition of as per NFPA. Now, this is one interesting, like, if you see the standard fabric, after 4 seconds and 6 seconds, it burns very quickly. Whereas this fabric, this was developed in UK first. It's a blend of preox and aramid, and it's backed up by glass fabric. And even after 21 seconds, there is no hole formation, and there's no shrinkage in the fabric. And this fabric is giving excellent protection against molten aluminum also. You can see this trial was done in a automotive company. They were using molten aluminum, and we tried to pour some, although it's not a standard way of testing it, but we just thought of taking a trial. And so we are now working on developing aprons and sleeves using this fabric, which can give them protection against flash fire as well as molten metal. And even the company has mentioned that they want a double side apron. So one side is protection against molten metals and apron, and other side they only want cut performance. So you can imagine you have a double layered apron. One side is ultra high molecular weight polyethylene for cut performance, and other side is your preox and aramid blended material. Now he will try to turn it around, and you'll see that there is no hole formation, and it is fantastic product. And once again, a lot of R&D is required to optimize this product to be used in Indian conditions. Arc flash fire, once again, flash fire happening because of electrical faults. It's a very new area, and unfortunately, all testing is still being done in Canada, and in India we don't have any lab which can test arc flash fire. So what we have done, we have developed a fabric which is manufactured using aramid blended with FR viscose and high shrink fiber. And the best part of this fabric is after knitting, this is 250 GSM fabric, but after dyeing finishing, because of the high shrink fiber, the GSM goes up to 450 GSM. It becomes 450 GSM, and it gives fantastic results against arc flash protection. I'll show this. These are the testing standard which were used by Canatrix to test our sample. We got our samples tested both in glove form as well as fabric form. This is a video showing the testing method. You can see the fabric sample before testing and after testing, and glove sample before testing and after testing. And we get ATPV rating, which is basically arc thermal protection value. In simple language, you can say like example, ATPP of 41 calorie per centimeter square means up to this 41 cal, this fabric can protect us from the onset of second degree burn as per Stoll curve. Once again, this topic is so big that we need a separate 1 hour session for just arc flash, talking about Stoll curve, which was developed by Alice Stoll in 1958, which is basically talks about amount of incident energy required for certain time so that to start the onset of second degree burn. So our ATPB of 41 calorie on a single layer fabric is a very good result, because most of the time you will see that you have a 2-layer or 3-layer fabric which is achieving 41 cal. Here we are talking about single layer fabric which is coated with neoprene, and this fabric is spun, knitted, dyed, finished, and neoprene coated, all done in India. Obviously, this glove is manufactured outside India, but the fabric we are able to manufacture. So now we are working on developing a lower GSM to achieve HRC level 2 or lower calorie levels, reducing the weight of fabric and hence making it more comfortable. So this is again a very interesting area for us. Thermal insulating roving yarn. Again, this is an interesting concept for smaller like companies like ours, where we try to increase the production using limited machines. So here, what we have done, we have studied two ways of spinning yarn. So one is, we know, ring spun yarns, and another one, what we did after speed frame, we took the roving and we did it covering using some fine count yarn, and that yarn can also be used for to knit on the 7 gauge or coarser gauge machines. Now, why we want to do it? The reason we want to do it, because we all know that blow room carding, draw frame, speed frame production per shift is very high. You can process 200 kg or 300 kg per shift easily up to speed frame. But if you have a limitation on ring frame, the production goes down, and after ring frame you need winding to make the finished yarn. So this was a very good concept. We are working on this concept for, once again, this is not applicable for finer count, because you can make we tried making 1.7 NE roving, and this glove we developed, and you will see the comparison when we compared two types of gloves, one using ring spun and other using this roving yarn, and we found interesting results on contact heat transmission. Because of roving yarn, it's less twist is there and more air is entrapped, so we are getting really interesting results for contact heat transmission, and the gloves are more comfortable. And if gloves can be knitted, we can always knit fabric also on coarser gauge, and this roving yarn can be very interesting to make apron or heavy GSM fabric. And obviously, yes, abrasion resistance won't be good because the twists are not high as compared to ring spun yarn, but we are gaining on thickness, we are gaining on higher production, and abrasion can be improved with help of some coating. So once again, it's very interesting concept for developing market, because here in this case, I don't have to worry about MOQ. If someone is saying that we need 50 kg of roving yarn, we can produce 50 kg, whereas in ring spinning, we need to take at least 100 kg or 200 kg. So MOQ is not an issue, and a lot of blending can be done, and it's easy to produce. And this area is also very interesting for us to for the research work. Now, this recycling of metallic cut resistant yarns, again, it's very important because with increase of usage of these cut resistant yarns, where steel wire is there or metals are present in the core, traditional way of recycling is not possible. And any glove or any protective textiles you take having metal inside, you have at least 50 to 60% of fibers. So when these products are thrown in landfill, we are losing high performance fibers, which we should try to recycle and reuse. Yeah, even I was surprised. Leading companies like Maruti, they are using uh, 3,000 to 4,000 pairs of metallic steel white gloves every month, and they are just burning it. You know, they are burning it. And I was so surprised because that we can we can try to uh, regain those fibers. So it's again very interesting area where we need to work on how we can recycle metallic yarns, which cannot be recycled in a traditional way like it's being done. Panipat is famous for recycling of textiles from all over the world, but those machines cannot be used for these gloves because of metal inside. It can damage the machine or circuit. So we are working on this concept, and um, a simple way. Right now, we are trying to develop. It's labor-intensive work. Different structures can be developed using these waste, and it can be coated with PU or nitrile, and different shapes can be created. And these shapes can be used as a for technical application. We are also trying to shed these waste into smaller fibers so that it can be used. Um, Finally, I'd like to summarize. Once again, it's very important to study these fibers from different suppliers because each supplier will say that we are the best, but it's time we need to have our own library where we compare different brands and um, once again it's very important because sometimes uh, few suppliers they have certain issues, and it becomes a problem for any spinning company if they are not aware of those problems. So it's important to compare with different brands available to understand what's the benefit, what's the problem. And wash care instructions, wash care study is very important. As I said, leading automotive company in India is still throwing those gloves, and they can wash it and they can reuse that glove for much longer period of time, and probably that will happen after 6 months or 1 year. That will happen, but right now we are not looking into washing and reusing these products, which is very important. If we talk about Indian market, MOQ is still a problem. Any company which is looking to get into technical textiles or these products, um, example for yarn, they have to place order for 100 kg. For a spinning company, we have to buy minimum a bale that is 250 kg. For weaving company, they have to buy 100 kg. So you're talking about these high value products which are in the range of $25 to $30 or maybe $40 per kg. So you're talking about 10,000 to 12 to $15,000 just for sampling and development. That is the reason smaller companies are not able to get into this. So through ITTA, we are working on creating a library of fibers, yarns, fabric. Even I'd like Textile Institute to join hands, and where we can issue up to 10 kg, 20 kg, or 1 meter, 2 meter of these products, so that lot many smaller companies can also get into. And um, uh, we have also requested a Ministry of Textiles to train more and more laboratories, more and more NOBL laboratories, especially to test the composition at least. Example, if a guy is supplying yellow cotton blended with aramid gloves, any lab should be able to test it very quickly. Because that's what happening lot many times, and we really need to strengthen our labs so that these products can be tested very quickly and can be certified very quickly rather than just waiting for a few labs. So with this, I'd like to conclude. Thank you so much. And I have shared website details where I have tried to put all my published papers and blogs, so if anyone wants, they can go through this and send me email. So yes, thank you so much. Thank you so much.
Thank you. So, Dr. Nandan Kumar, with your over 15 years of experience in the field of protective textiles, with being a bachelor of textiles technology from NIT, Jalandhar, Punjab, and being the PhD from the University of Leeds, UK, with being the finalist at the NatWest Business Plan competition, winning so many business plan competitions and which were organized by the University of Leeds, UK. He has given a lot of motivation to many of the young researchers, and many talks and sessions where you have openly shared your valuable knowledge and your skill that you are practicing and trying to bring and empower people and the textile industry. So we have been honored and have had a good learning experience. This program is jointly organized as a knowledge partner with ETA. So I would now request Dr. Anup Rakshit, who could then brief us more on what is the further research scope in this area, so we can network and collaborate together. Thank you.
Thank you very much. So first of all, good evening to all of you, particularly Mr. Roy, Dr. Vishakha, Dr. Nandan, and entire TI team. And it is my privilege to be with you today and share my thoughts with you. And as I understand that there is a combination of major participants are from the academics area, and some of them are from the industry as well. So I tried to just talk briefly about a couple of things, which mainly our relationship between ETA and Textile Institute. Then I would like to give you some information about that funding opportunities on R&D projects. I think that is a burning problem of all the universities and colleges or the research institutes. But there is an opportunity which is still running, and it is just on. So these are the just I will briefly touch upon these areas. See, first of all, you have heard Dr. Nandan, and Dr. Nandan is a very learned person, and his company and ETA trying to do for the academics a lot, and the research scholars a lot of things which he also mentioned. We are trying to create some kind of a fiber bank, where you see the problems which he mentioned, the fibers which are costing something like $30-40 per kilo, is very difficult to make these samples. So I really appreciate his company, how he has set up this small spinning lots of the, that in spinning industry, small lot is a very big problem. But he has still done that, and it is very appreciated. Now, particularly if I just briefly touch upon our relationship with Textile Institute Manchester and also their chapters in India, we have actually signed a memorandum of understanding with TI UK. And what are the major areas under this is the knowledge dissemination through this type of seminars, conferences, exhibitions and all. Second is all our ETA members can avail of their membership, either it's an individual member, corporate member, and different types of membership categories of Textile Institute Manchester. They can also avail at a discounted rate if they are ETA members. Second and third is that the TI has got very important and knowledgeable publications. Those publications are also offered, TI has offered to ETA members at a discounted rate. So these are a couple of things which we are doing. Plus, we actually in Indian chapters, there are 4 in India, and particularly active is both area in the north and the west. So we have already done some programs with NIST in Delhi before this COVID problem, and now we have started doing with WIST in the western regions. And I appeal to the eastern and the southern region also to join hands with us so that we can take this relationship much at a higher ups. Now, most of you know about this Indian Technical Textile Association, but I just briefly tell you in few words that this organization was set up with the behest of the Ministry of Textiles in the year 2010. So this is actually 11 years young organization, and it started with a very small beginning when the technical textile not even was heard in the textile fraternity, mainly to promote this technical textile concept in the Indian industry. And from there, it started with I think 40-50 members, and now today we are nearly 400 members all over India. And also we have got members abroad from Belgium, from Taiwan, and various other countries also. And we have such type of memorandum of understanding with EDANA, INDA, then TTTI, that is Technical Textile Association of Taiwan. So this is briefly about this our the whole relationships, which I hope that in future we will be able to build up much more and have more and more such type of programs. Now coming back to the main thing, which you heard that the various hurdles and the problems which are faced by the small development and the innovation product development area. And the technical textile is a product which doesn't sell per se as a standard like 30s count, 20s count, or so many ends and picks in the mass market. These are all specification oriented product, right from the input material to the finished fabric and the garments. Each and every stage you have to control your quality and you have to adhere to the specification. If anything goes wrong, then your entire effort of the development and entire lot of that product is going to be waste. So one has to be extremely careful when we are developing the product. First, one has to acquire the knowledge, and right from the selection of the material, which you heard from Dr. Nandan, and then what you are going to deliver to the customer and the user, that is your ultimate customer, not in between. So all these stages you have to stringently control your quality to deliver the specification which is required. Now, and we always these dearth of the fund, for I am coming to this particular point where I wanted to tell you some information about the R&D thing. Before that, I just want to tell you that we have actually, I want to show you a small video of only about 2 minutes, which will give you some glimpses about the various innovative products, not only protective textiles, many other areas also. So just give me a moment, I'll just start the video.
How does one get an idea to create?
Is this audible to all of you?
Yes, sir, it is audible.
Is audible, no?
Yes, it is audible.
Okay, so let me start.
How does one get an idea to create a successful business? The most successful ideas of our times, like Coca-Cola, Huggies diapers, or WhatsApp, for example, have been novel ideas with mass appeal. Since India is a textile powerhouse, why don't we look for such ideas in the textile, particularly technical textile industry? Imagine a raincoat that weighs only 100 grams and fits in your back pocket. Everyone will carry one in the rainy season. Our cities are among the worst sufferers in air pollution, and an air purifier is mainly made up of filter fabrics. Imagine the number of people in India who will use air purifiers. Imagine fabrics as building materials, concrete reinforced fabrics for building, architectural canopies, why even lightweight shamianas. Imagine bandages that make wound healing faster, mosquito repellent clothing which saves thousands of lives. Imagine crop covers that save moisture and even protect fruits. Think of RF shielding fabrics that are used in data protection, even in military camouflage. Textile products for emergency evacuation from high-rise buildings. Imagine inflatable products, filtration, parachutes, signage fabrics, chemical and viral protection, and many, many more applications. Welcome to the field of infinite possibilities, where your imagination can make things come true. Welcome to Technical Textiles. Come to us and we will guide you to the right sources and partners. We are ITA, the voice of the Indian technical textile industry.
Okay. So
Thank you, Dr. Anup Rakshit, for your informative presentation. That's a video and about ETA.
and I just
We
want
look
to
forward
share
to more. Yes, yes, sir.
just in another, I need another 2-3 minutes to tell you about the
Surely.
details about the one which I was telling about the scheme thing, which will be very useful to all the academicians and colleges. So is it that I have to open the share tray, is it? Just
Yes.
a second. Is it visible?
Not as yet.
Not as yet. No. What is happening? Is it now?
Yes, it's turned on. Yes.
So here, so I will just start. It is not in the PDF form. It is in the Word file. So this is what is the major information. The earlier one, which was just I told about that ETA only, but the funding program which I was telling you, many of you may know that there is a called National Technical Textile Mission launched by the Ministry of Textiles. Now, under this scheme, there is a R&D component of 1,000 crores. Now, how these projects are going to work is a combination of the industry and the universities and colleges. So these together, then it is just like a concept which very commonly and it is practiced for ages or for the decades in the European or American universities or Japanese universities. Now here the combination, unless these two industry and the academicians are jointly work together, the result will not come out. The ultimate goal of any research is to have as the main aim should be the commercialization. So to promote this concept, this type of fund, it's a huge fund has been created, and there are almost nearly 100 crores have already been allocated. Many of you may know, might have got also. But now this scheme is on. So I want to give the message to your all academicians in the university colleges, whether it is IITs, NITs, individual universities, and all these people, they have an opportunity to work together with the industry. Now these are the 5 different areas where the proposals, these research proposals are invited under this scheme, and we ministry have been asking us to coordinate with them. We already have number of projects submitted and number of projects are in the pipeline. Mainly the areas which are now focused is sport tech, meditech, mobile tech, biodegradable technical textiles, high performance fibers. But earlier, out of these 12 segments, you all may know in technical textile, other segments have already work has started and the projects have come. So this document I can share with TI, with Dr. Vishaka. They can actually send it across to all the participants. Now these are some of
Surely.
the identified areas which I am not going through because of the time shortage. These are the areas where projects have been submitted. So other than these areas, the ideas and the projects can be submitted. Now, some questions may come to your mind, where do I get this industry partner? And I think that is the question we are also facing from our industry members, that where do I get my partner in the institutions or universities? So I said we can facilitate this process, but you come out with the ideas. Now ideas have to be generated by the industry. What industry needs, there has to be, academicians should understand that this is the need of the industry, means that is the need of the country, of that particular technical textile industry. And the focus of this scheme, or in future, if we are able to make this concept successful, then we have done the job. That is how the other Western countries have progressed on the innovation and development front. Okay, so with this, I will end my talk. If there are any questions, I would be glad to reply. Thank you very much.
Thank you, Dr. Anup Rakshit. So we have Mr. Timir Baran Roy, who is the chairman of TISIG, and under his guidance and his real start thought that we should be having a real good session on research aspects, we invited Dr. Nandan. And Dr. Nandan always likes to have these sessions offline because he likes to demonstrate all the pieces. But after a long wait, we finally decided to have this online. So glad to have you, sir. Timir, sir, you'd like to share some feedback. So your mic is off, if you can turn that on.
You are still in mute.
Yeah, sir is in mute as yet. Yes, sir. Okay. So I think he has some technical issues, and now we would like to take questions till he gets his system device sorted. So there are no questions in the chat box except for one that I could spot. Yeah, can I ask, has anyone come across, this is a question by Miss Helen Colborn. Can I ask, has anyone come across a nano quantum conducive textile that has antibacterial properties? And would this need to be a dual core yarn of the type that you have described? So this could go to Dr. Nandan.
Thank you, ma'am. I think what she's talking about the nanofibers, the nanotechnology side. So whereas we are talking on the micron side, so we really need to. I mean, I have few colleagues; they are into nanobiotechnology and they are trying to develop some conductive polymers using viruses. Maybe I can ask them. So I'm sorry, I won't be able to comment on this question. But I think it's technical. But if I can get her email ID, definitely I can connect her to a few of the leading researchers on nanowires. Few of my colleagues, they are still working at Leeds University and they are working on nanowires. I can connect her to them. Probably they'll be able to.
Yes, so Miss Helen, you could write in a mail to Dr. Nandan and probably he'll get you connected to the right person. And any more discussions or any more clarifications or opportunities that you would like to tap right now? Okay, so then we could, sir, Timir sir, are you able to unmute? No, we still can't hear you. Okay, are there anybody in the audience who would like to voice out anything? Or we can call it a day. Now, this is the feedback link that I have posted in the chat box. So do feel free to give an honest feedback, very objective, open one, and we will make sure that we can get more connected. We can then collaborate further and take on more research projects in the right direction under the guidance of ITA and under the guidance of Dr. Nandan. Thank you, Dr. Rakshit.
I think there's one question. Have you
Yes.
worked with Vectron? If not, why not? If not, why not? I mean, honestly, we have not worked with Vectron in India. Probably.
James, sir, if you could tell us, because what is Vectron? Briefly, if you can just tell us what is Vectron. I hope the rights to open the mic have been opened up, right? Yeah, okay. So James sir has said it's a liquid crystal polymer fiber. Okay. And which is a polymer, sir? What kind of polymer are you actually having?
This is basically aromatic polyester.
Okay. Vishnu sir has answered. It's aramid, yeah.
I mean,
yeah, aromatic polyester, basically.
Aromatic polyester. Okay.
It's not aromatic.
This is available in India. If it's available, definitely we'd like to test it. Example, the first time Reliance has manufactured ultra high molecular weight polyethylene, and we are lucky to get a sample to test it. So tomorrow we have a call with Reliance team talking about ultra high molecular weight polyethylene. We have tried to make gloves out of that. So yes, if you can connect us to Vectron, or if we can get samples, definitely we can try it. We can do some development and we can test it. So why not? As I said before, it's about having that fibers or materials available in India on regular basis. Then it makes sense for us to develop something. Otherwise, if we develop everything and then end of the day we realize, like PBO, that fiber we cannot buy it because it's controlled by Japanese government, so then it's just waste of time for us. So,
okay, Ms. Tripti Gupta has put in a question. Can the molten metal protection be attained only through coated fabric, or IFR can be used? Also can be used.
It depends. Because of price issue for molten iron, most of the time coated cotton is still being used in India most commonly. But we have demonstrated, if you have IFR fibers like Priox blended with wool, or that sort of concept can be developed and tested. So it depends if we are talking about which metal we want to focus on, whether it's iron or aluminum, or so based on that we can develop. I think Andy has mentioned, Andy Ogden, he is also director of HPT. He has more experience. He has mentioned something about in the chat box about Vectron. I believe he has having experience.
Yes, limited to UV stability with similar thermal and physical properties as other aramid materials are very expensive.
Yeah, that's the main.
Yes, I will forward Dr. Rakshit's Word document. So we are looking at funding, sir. Everybody is keen on having funds pumped in. Yes.
I know, that is what I thought to give this information to all the participants.
Thank you so much.
And I am sure we will be glad to help you. And if necessary, we will connect you to the right industry partner as well.
Great.
And somebody has written about that Kurare. The Kurare is also ITA member. And if any information required, Andy has written that.
Yes.
So this
it's made and exclusively made only by Kurare,
Kurare Japan. But Kurare Japan is also promoting their fibers in India, and they have offices in Delhi and Bombay, and they are also an ITA member. So if you need any help, I can get you connected with the country head of this Kurare Japan, Kurare India rather. Okay.
That's fantastic. Thank you, sir. Vectrin is produced in USA, says James, sir.
That is a brand name of that company.
Okay. So Timir Roy, sir, I'm so sorry that you're not able to turn on your mic, but he says heartfelt thanks to all those who have participated in this event and hope we are going to really benefit. And of course, we have benefited from Dr. Nandan's presentation. Many concepts really brought to surface. Thank you. So we will close the session. I hope everybody has filled in the feedback form and you would receive a certificate of participation or attendance in your registered email ID. Thank you one and all, and we look forward to more collaboration. Thank you.
Thank you. Thank you so much.
Thank you.
Thank you.
Thank you.
Namaskar to all of you.
Thank you. Stay safe, everybody.
Right.
Thank you. Best regards from Czechia.
Thank you, sir.